Welcome back to Rock the JVM, folks. This is Daniel, and this is the second part in ZIO streams, where I'm going to show you error handling. Now, this will rely on the first video that I just released on ZIO streams, so you can check that out if you don't have the necessary prerequisites. Also, I'm going to assume that you're comfortable with Scala and that you have some essential ZIO knowledge, which I also teach in my ZIO course, which I've just launched, and you can find that in the description as well. As always, I recommend that you make the most out of this video by writing code with me, and whenever you need to refresh your memory, just refer back to the video or to the blog, which has detailed explanations of everything that we discuss in this video. Alright, now I'm going to switch back to my development environment where I have an application that I called ZIO Streams that I started in the previous video, and I recommend you check that out if you haven't watched that already. I discussed what effects are, and I'm pretty sure that you already know that because we're relying on ZIO, of course. And in the previous video we discussed the crucial components of streams, which are Z-streams, also known as sources, of 0 or more potentially infinite amount of elements of the same type, and we discussed what you can do with these sources. We also talked about sinks, which are destinations of elements, and these sinks can do a variety of things, including leaving things over, which explains the 5 type arguments of a sink, which is pretty crazy. And then we discussed some functionalities that sources, sinks, can have in combination, and we discussed how we can combine streams with sinks. And then we talked about pipelines, which are nothing more than transformers that you can insert along the way if you want to do something with your data elements and process them as they go through your stream. Now, in this video, I'm going to deal with failures. So I'm going to have failures or errors and handling them. ZIO takes errors very, very seriously, which is why every ZIO effect type has the second type argument denoting the error type, and you can treat these errors in a variety of ways. I teach that in the ZIO course. Now, specifically for ZIO streams, I'm going to give you some techniques on how to handle errors. First of all, let me show you how you can fail a stream manually. So I'm going to have let's call this fail stream as a Z stream that is a source with no requirements, no dependencies, string and int. And Z streams have the same type arguments as a regular ZIO. So we have the environment or the requirement dependency type. The first one is any, meaning that we have no requirements. The error channel, which is string, and this stream will produce elements of type int. And I'm going to have, let's call this Z stream of, let's say, 1 and 2. And you can concatenate streams with a plus plus. So I'm going to have a Z stream dot, and you can use fail, for instance. And I'm going to fail with a string because that's how I specified that in the channel. So I'm going to have something bad or a bad feeling about this or something like that. And I'm going to have a Z stream with some more elements like 4, 8, and 5. So you can fail a stream manually by doing zstream.fail with the error type, which is the same as the description. Obviously, if you don't specify the zstream type, the compiler will usually infer that for you. Now, let me give you a more complex example of a stream that is processed out of a regular Java input stream that might fail with a throwable. So I'm going to define a class. Let's call this fake input stream with a T, which is a subtype of throwable from Java. And let's say that this fake input stream will want to read characters or want to read integers out of a stream of digits and push these digits one by one. And at a particular index, I want this stream to fail. So I'm going to pass, let's call this fail at as an integer. This is going to be the index at which this stream will fail. And let's say fail with, and I'm going to pass the exception or the error type T here by name. So I'm going to have a by name argument of type T, and this extends input stream, an input stream from Java IO. So the plain old Java IO input stream. So I'm going to have a val called data, and this is going to be an array of bytes that I'm going to push because this input stream will require me to push bytes to the output. So an array of bytes, and this is going to be a string like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I'm going to extract the bytes out of that, so get bytes. And I'm going to assume that the fake input stream So I'm going to require to implement the read method, and the read method will push an int. Now I'm going to consider that this read method will return an int, and by the specification of the input stream trait or interface, I need to push a byte, which is wrapped as an int, and I'm going to return every single digit of the string one by one, and whenever the counter or the index overlaps the string, I'm going to return it back to 0. So I'm going to define a small var. I'm going to call this counter, which is an int, and I'm going to start at 0. And I'm also going to define an index, which is an int. I'm going to start at 0. And for the read method, I'm going to consider that if the counter is at some sort of limit, which I'm going to add here, so limit as an int. So limit as an int, fail at as an int. So if the counter has reached the limit, I'm going to return -1, which means stream end. Otherwise, I'm going to check if the counter is fail at. So I'm going to throw the fail with, the exception that I passed there. Otherwise, I'm going to move my index a little bit. So I'm going to say val, let's call this result, as data at the particular index. And then I'm going to move my index. So index is, I'm going to say index +1, and then I'm going to mod that. So I'm going to say mod with the data.length. And I'm going to increase my counter. So counter increase by 1, and then I'm going to return the result bytes. Okay. So this is the read method. Now, with this fake input stream, I can turn that into a ZIO stream. So I'm going to say, let's call this non-failing stream. And I'm going to instantiate a Z stream out of this fake input stream thing, which is a very classical example of an input stream with some internal data, internal mutable data, so that read actually produces side effects. So we want to hide that out, hide all the potential side effects, and abstract that away as a Z stream with functional programming primitives. So this non-failing stream is going to be a Z stream of, let's say, any, so we don't have any dependencies. This can fail with some kind of, let's assume, IO exception, for instance. And I'm going to produce, let's say, strings, so string, and I'm going to use zstream dot from input stream. So there is a factory method that wraps a plain old Java input stream and turns that into a Z stream. So I'm going to have a new fake input stream with some parameters. So I'm going to have, let's say, 12 items failing at 99, and I'm going to have a new IO exception because that's the type that I specified here. So new IO exception with, let's say, something bad. And I'm also going to have the zstream.fromInputStream has a second argument, which is the chunk size. I'm going to have my chunk size equal to 1 because I'm going to read character by character. So chunk size is equal to 1. And then I'm going to map all these bytes because this input stream will give us bytes. I'm going to wrap each byte and turn that into a string. So I'm going to have a map, and from every byte, I'm going to return a new string out of an array containing that byte because there's no other way of wrapping that. So we have a from input stream and mapping every byte to a string, which pretty much reads every character in turn. Okay, cool. So this is an example of something that will not fail because the limit is 12 and failing at 99. So the stream will end before we reach the failure counter. And let's assume that I want to collect all these characters one by one and displaying them to the console. So let's say, let's call this sync as a z sync of, and I'm going to have to pass all the parameters here. So the environment is any, the error type is nothing. I'm going to wrap that as nothing. I'm going to consume strings. I'm going to leave over nothing, and I'm going to produce a single string value. So this is what the type argument means. And I'm going to use a constructor called zsync.collect, so collect all. And zsync.collectAll returns a chunk of strings. So I'm going to say collect all with string. I'm going to add the type argument here because the type infer doesn't always do the job. So we have a chunk of string which contains all these bytes. And then I would like to compact that chunk, so turn that chunk into some sort of single string. So I'm going to say map, and for the chunk that I obtain, I'm going to use chunk dot, and there's a constructor make string, which is very similar to regular collections. And let's assume I pass this little dash in between two characters. So we have a stream, so a Z stream and a sync. I don't know why the sources are called Z streams. I think they would probably be better called Z sources or something like that. Anyway, so I'm going to connect this one to the sync. So I'm going to have, let's say, as the run method, I'm going to connect these two. So I'm going to say non-failing stream dot run with the sync. So this is a ZIO, and then I'm going to say debug, which will print the final result to the console. So let's turn this into a runnable application and let's see what we get. So we should get the first 12 characters out of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 characters and then another 0 and 1, which is being printed to the console. All right, so this is an example of a non-failing stream running with a sync. Now, let's simulate a failure. So let's call this failing stream. So failing stream, again, as a Z stream of any, this can fail with an IO exception, so I'm declaring the exception type, and the string produced values. And I'm going to wrap this Z stream dot from input stream, and I'm going to pretty much copy this and paste it here. I'm only going to change the arguments. So let's say that I want 10 characters, and I'm failing at index number 5. So I should be failing at 0, 1, 2, 3, 4, and then at 5, I'm going to fail. Okay. So let's try running this one. So I'm going to have failing stream.run with the same sync.debug, and let's see what we got. All right, so we get a failure. So we have something something bad. Stack trace for a thread, and this is a ZIO fiber that runs this stream. So we have a stack trace, and you can inspect the cause of the error. So this is an example of a failing stream which wraps some sort of Java input stream and it fails internally rather than having it fail manually with zstream.fail. All right, cool. Now, I'm going to show you an example where we can fail, but the error type doesn't really match the declared type. So I'm going to have, let's call this val, I'm going to have defect stream. In the ZIO course, I talk about failures, that is errors, and defects. So errors and defects are different in the sense that errors are being declared on the error channel of a ZIO, or in this case, because we're talking about streams, is being declared on the Z stream. But defects are those errors that are unforeseen, so they may not be reflected in the type signature of the stream itself or the ZIO effect. So this defect stream is a Z stream with any IO exception and string. So I'm declaring my desired or the kind of error that I want to handle. But I'm going to paste that. So let me first of all correct my spelling mistakes. And let me copy the code and let me use a different kind of exception. So instead of a 10.5 with IO exception, I'm going to run a runtime exception. And let's say something unforeseen. This will pretty much throw this runtime exception, so the ZIO itself will not be that different, but it's just that this runtime exception has not been caught. So notice that we have a die here. A die means an outcome of a ZIO, which has not been foreseen. We said earlier that an IO exception is an error, and that failing stream caught or could handle that sort of exception. So the output was different, but here we have a die with a runtime exception, and we have the entire stack trace of that fiber. All right, so let me show you how we can do recovery. So as with ZIOs, Z streams can also recover from errors. So let's say that if I get some sort of exception or error as declared here, I might want to return a fallback Z stream. So I'm going to have my val, let's call this recovery stream as a Z stream of a larger error type, let's say any throwable and string. And I'm going to use a Z stream built manually out of some strings like A, B, and C, or something like that. I can say in my override def run, let's call this recovered effect as failing stream, and I can say or else recovery stream. So in the case that the failing stream fails, the recovery stream will be returned instead. So this recovered effect will be run with that same sync. And in my run method, I'm going to simply call or use recovered effect.debug. So let's see what we got in this case. All right, so we have 0, 1, 2, 3, 4, so the first 4 elements, and at the point at which the original stream failed, recovery stream is used instead, and of course that finishes after 3 elements. So we can continue at the point of failure. So we have or else, which will chain a new stream at the point of failure. There's also a version of or else, which is called or else either, which will turn every incoming element from the original stream into a left and the recovered one into a right, so that you can tell which item comes from where. So the stream that you obtain at the very end is successful in this case, but if you're interested in checking which pieces, which parts belong to or come from a stream that originally failed and which parts come from the recovered one, there's also or else either. So I'm going to have, let's say, val recovered effect version 2, assuming I can spell properly, and I'm going to have my failing stream dot or else either, and I'm going to have my recovery stream. And this is a Z stream. At this point, I haven't run it with the sync. So this is a Z stream of any throwable and either with string and string. So the left one comes from the failing stream and the right one comes from a recovery stream, if that is the case. So this is a recovered, let's call this recovered with either. And I can print all these eithers by saying recovered with either. I'm going to run with a sync. So I'm going to say Z sync dot for each, and I'm going to say ZIO dot succeed with all the values inside, and I'm going to debug every single effect. So zsync dot for each will take every element that will go in the sync and will run this effect on top of that, and I'm going to debug so that we can print all the items to the console. So let's run this out. Let's see what we got. So we have left with 0, 1, 2, 3, 4, and right with ABC. So the left ones come from failing stream, and the right ones come from recovery stream. So this is or else either, and this will turn all elements from the original stream are left. All elements from the fallback one are a right. Okay, cool. So we have or else. I'm going to show you how to catch exceptions or errors, and I'm going to have my, let's call this caught errors as failing stream, and I'm going to use a construct which is very similar to the ones that you see in the regular zeros, which is catch sum, and catch sum takes a partial function from an exception type that is specified in the ZStream's type signature, and you can return another stream in that case. So we can have a case for anything, which is an IO exception. I'm going to then return recovery stream. And in this case, I'm going to use caught errors dot run with sync, and then I'm going to say debug. So caught errors will not change the type signature of the original stream. So we have 0, 1, 2, 3, 4, and then at that point we caught the IO exception, we stop the original stream, and then we follow with the next one. So catching, there's also catch some cause, which inspects the cause of the error, including the potential death from an error which is unforeseen or unspecified in the type signature, so a defect in that case. We also have catch all and catch all cause. So notice that we have the cause modifier in both of them. Okay. The final thing that I wanted to show you is how to turn every element into an either containing the potential error. So I'm going to have, let's call this error contained as failing stream, and I'm going to use either So failing stream.either will return a Z stream with any nothing, and it will turn all the values into either an IO exception, just for that one which failed, and write with strings for all of those which did not. So I can say error contained, and I'm going to run with a Z-sync, and I'm going to use collect all so that we fetch all the values inside. So collect all, and then I'm going to debug with, you can also add an argument, but I'm not going to add one. So we will have a chunk which will contain all the right values which were successful, and the final one which failed is a left containing the IO exception and all the data, including the stack trace, buried within. So you can inspect that exception and contain that as a proper value that you can then inspect, recover from, eliminate, log, trace, and so on and so forth as you see fit. All right, so this was a brief overview of how to handle errors in ZIO streams. I hope you liked this video. Click the like button for me and subscribe if you want to see more of that. Check out the ZIO course. This deals with everything in the ZIO effect system, so the core ZIO library, if you want to check that out. And check out my Rock the JVM channel here on YouTube for more videos like this. Check me out on Twitter and LinkedIn for fresh updates on upcoming material. And check out the Rock the JVM website. I have hundreds of hours literally on everything in the Scala ecosystem. So until next time, folks, I'm Daniel, signing off.